So we also have general and one-sided limits. So we have a theorem in math that says that the limit as x approaches c of f of x equals L. So this is what we call the full limit, or the general limit. So the full limit equals L if and only if the limit as x approaches c from the left equals L, and the limit from the right equals L. So all that means is that the left and the right side have to approach the same y value for the overall limit to appear. If the left and right approach different numbers, that means that the overall limit does not exist, but we can still evaluate limits from one side. So a great function to talk about this with is the one that you see on your screen. So we have f of x equals the absolute value of x plus 4 over x plus 4. So if we wanted to say find the limit as x approaches negative 4 of f of x, right? If we plug in negative 4, we get a 0 over 0. So whenever you get a 0 over 0, and we're going to talk about this later in the year, that's called an indeterminate form. So we need to use another method in order to figure out what's happening. So one thing that's super helpful to do is maybe draw a picture if you can figure out what's happening. Right, so in other words, we want to evaluate the limit as x approaches negative 4 from the left and as x approaches negative 4 from the right. Okay, so let's do from the left first. So numbers from the left are like negative 5, negative 4.9, negative 4.8, right? As we get closer and closer to negative 4 from the left side of the number line. So say we just plug in negative 5, right? That's pretty far away in terms of like numbers, but if we plug in negative 5, I would get the absolute value of negative 1 over negative 1. So that would give me positive 1 over negative 1, and that's negative 1. Right, so if we think about it, right, the value inside the absolute value and the value in the denominator are always going to be the same, but the value in the denominator on the left is going to be negative, whereas the absolute value in the top is always going to make it positive. So we're always going to get a positive over a negative, so we're always going to equal negative 1. Whereas as we approach from the right, say like we plug in positive 5, right, we get 5 plus, not positive 5, that would be really far to the right. I mean, it's still to the right, so we could do that. Why don't we plug in negative 3? That makes more sense. So if we plug in negative 3, right, we get the absolute value of 1 over 1, right, and that's just equal to 1. And that makes sense, and that's going to always be true for any number to the right of negative 4, because that absolute value sign in the top is actually not needed, because any number that's smaller than negative, well, bigger than negative 4 technically, right, to the right of it, plus 4 is going to be a positive value, right? So you don't need the absolute values there, so you're going to get the same number over itself, so you're just going to get positive 1. So because we have on the left approaching negative 1 and on the right approaching positive 1, the overall limit does not exist. So College Board loves this function, and it's helpful to know what it looks like. Whoops, what is happening? So this function, right, 4, so it's not defined at negative 4, but to the left of negative 4, it's always going to equal negative 1, and to the right of negative 4, it always equals positive 1. Excuse how poorly drawn my graph is. There we go. Right, so that's what that function looks like, and they like to throw this in a lot, not with necessarily the x plus 4s, but other things. They also like to look at one-sided limits and general limits using graphs. So let's do a graph example. So we're going to use the graph of g of x below to evaluate these 4 different limits. Okay, so as x approaches negative 2 from the left, right, we're coming up this direction, right, we're approaching that y value of negative 1. And now as we approach it from the right, we're coming down now from the right side. Right now we're approaching positive 1 as our y coordinate. Okay, it's going to bug me that I didn't do this. There we go. Right, and now as we approach positive 2 from the right, so we're starting on the right side of 2 and coming towards 2, we're approaching a y value of 1. And then as we approach 2 from the left, right, we're approaching that y value of -1. Right, so it's just paying attention